Thank you, Chair. No slides from me, and I will try and take less than the 10 minutes because we might have a chance of some round of questions after this. Firstly, an introduction to European Climate Foundation won't be familiar to everyone. The ECF was established in 2008 as a philanthropic initiative to promote climate and energy policies to cut Europe's greenhouse gas emissions and help it play an even stronger leadership role in international efforts to combat climate change. For me, it's a great pleasure to be among old friends here at the OECD. As you can tell from my accent, I'm not European, but I used to be the Australian ambassador to this place, and my chair was just over there, where Andre's sitting. And my role now at ECF is running the Finance and Economics program, which thinks of private finance in particular as a catalytic element in delivering the low-carbon transition. I'm grateful for both of the presentations for making my life as a discussant easier with stimulating ideas I know we're anxious to delve into. Let me pick up the question we've discussed in several places today already of non-linearity and make a very obvious point in relation to the climate. When it comes to the low-carbon transition, we don't really have a choice about non-linearity. Linearity will boil the planet, simply because we have left our mitigation task so very, very late. Let me put some numbers around that. Jim did a version of this with his circle diagram. Many of you would be familiar with the mathematics as outlined by John Schellenhuber of the Potsdam Institute many years ago, actually. I think it was just before the Copenhagen talks. He took the carbon budget we need to stay within a plausible 2-degree warming outcome. And if you manage to peak global emissions in 2010, some chance, you only needed to cut emissions by 2% per annum to be on track by mid-century. If you waited until this year, 2015, you have to cut by 3.6% per annum thereafter. We now know we've missed both of those exit ramps. So if we peak in 2020, it's cuts of 6% per annum thereafter. If it's 2030, and the Chinese emissions in their INDC are peaking in 2030, it's 22.6% every year thereafter. These are the mathematics of what I would call taking the 2-degree corner, but taking it very wide. So you go up above effectively a plausible trajectory to the target, and you have to come down quickly, and that's what I mean by non-linearity. When you considered these figures in 2010, we were plausibly in a linear world. Noting that, of course, the 2 degrees itself is a political guide rail only. It's superimposed on a massively complex and unpredictable system that is the global climate, but let's accept it. But cutting global emissions 2% a year for 40 years is a relatively gentle linear decline. It's not that for developing countries with a higher carbon path already. But I think we can all agree once you get to requiring cuts closer to 20% per annum in emissions globally, they will not plausibly be delivered by a linear process. This is why thinking has shifted within the European Climate Foundation and elsewhere to look for the tipping points and exponential dynamics that can plausibly deliver emissions reductions at the pace required. It's why we now have programs, as of relatively recently, on finance and on innovation. We've talked quite a bit about innovation already in this session. Since we've spoken about it, let me briefly finish with an example from finance, because I think it gets the innovation and policy nexus. One of the best chances we have as a species of making this transition is, of course, the power law properties that appear to adhere to renewable energy and battery technologies. Solar voltaic modules have fallen in cost, as we know, and was discussed earlier by Jim, by 80% since 2008, a statistic most people know well. The trick, though, is getting those cost dynamics to grid parity, seeing the solar and fossil fuel cost curves intersect and one pass below the other, and the penetration of solar or renewables taking off. If only it were as simple as that. And I think it intersects with the work that we've heard earlier in this session. There's a huge amount of public policy influence over when the renewables curve intersects the fossil fuel one. Part of it is the subsidies, most of it, of course, not the subsidies you're thinking of, subsidies to renewables, rather subsidies to fossil fuels, which outweigh renewables and subsidies by about 5 to 1. If you're not subsidising the fossil fuels, then the fossil fuel curve's higher and you cross it faster. But a very big part of it, I would submit, is the cost of capital. which, since operating costs of solar and wind, for example, are negligible, the cost of capital is crucial for the competitiveness of renewables. And how quickly grid parity arrives depends on how quickly you can get those costs of capital down. That's why I spend most of my time in my program thinking about the public policy set that influences the cost of capital for renewables, feed-in tariffs, market rules, curtailment policies, even bank capital requirements. I could go on. And predictability of policy is critical. Where there have been reversals of policy, such as renewables support in Spain, just to take one example, you see the spike in the cost of capital immediately, which makes me worry very deeply about policy gyrations in the UK recently, which seem to be taking on a slightly Australian flavour. I've touched on a very deep and complex issue only very superficially, but the basic point is that the power laws are there to deliver the transition that we need, but public policy can speed or impede the operation of that law. And this is where the policy expertise of the OECD and member governments becomes so important. Thank you.
Thank you very much, Chris. Due to the excellent timekeeping of our participants, we're actually going to have some time for discussion and debate. We'll be going till about 4:15, and then we'll be having John Giannakopoulos by video. But before I just open it up for general questions and comments, just a very brief comment. Both Simon and Chris mentioned the importance of nonlinearity in climate effects, and I was at a recent event with Nick Sturm, Giannakopoulos, but please thank our panelists.